Docker is a very popular platform for containers, but there's one thing that concerns me about it. Containers are run using the root account. Now, the developers did make it possible to run containers using a non-root account, but that's not part of the default installation process. So, why not use another platform like Podman? Well, what sets Podman apart is that it's daemonless and its default installation makes running containers more secure. But how do you install Podman and run containers? Well, if that's something that you're interested in finding out, then stick around and watch this video, as that's what we'll be going over. Now, installing Podman onto a Debian distro is about as easy as it gets. First thing we need to do though is just make sure that our package information is up to date, because we want to make sure we get the latest version. So running sudo apt update there. Then what we're going to do is to install Podman. So sudo apt install Podman, and I'm just putting in that -y parameter just so I don't have to answer a prompt. And then off it goes and installs Podman. Well, Podman has now been installed on the computer, but before I actually start to use it, there is one last thing that I'm going to do. And that is, I'm actually going to reboot this computer. And the reason being is that if I don't, what I found is you actually start to get error messages when you actually try to use the command to run containers, for instance. Now, running containers with Podman is pretty much just the same as it is when you're using Docker. So, for example, I'm just going to copy and paste in a command to run an Apache web server, for instance. So we use Podman instead of Docker, then you've got run, -d because we want this to run in the background, -p because we want to specify our ports. In this case, the actual web server we're going to run is going to be using port 80, at least from the actual containers perspective, but we're going to present this to the outside world on port 8080. Then we're going to tell it that the name of this is going to be web server. Then I'm referencing the actual image. So I'll hit return. And off it'll go and download that version of HTTPD, in other words, the Apache web server. And then once it's got that, it'll then actually run that in a container. Well, now that we're back to the command prompt, we can actually test to see if our web server is actually working. So, for example, what we could do is open up the web browser and try to connect to the actual web server through our web browser. And there we go, it's coming back and saying it works. If we go back to the command line, on the other hand, we can just try the curl command. So because this is the actual same computer that we're running our web server on, I can just point it to itself. So just hit return and there we go, we're getting entire HTML code there. Now, if we want to actually have a look and see what containers we're running, similar to Docker, except we're using Podman for the command, then PS, then -a is the parameter. It's coming back and giving us details of what actual containers we've got running. And if we actually want to stop the actual container, well, Podman, then stop, and then the name of the container. So hopefully, as you can see, this is pretty much just the same as using Docker, except we're using the actual Podman command. Now, as I was mentioning in the intro, one of my concerns around Docker is the fact that with the default installation, when you start to actually run containers, those are actually being run by the root account, which isn't really good from a security perspective. And that's the benefit of Podman, because it actually runs these as rootless containers. It actually runs them using your user account, which is a lot better for security. So what we're going to do is to actually start our web server up, or at least we're going to try, because this is a feature, shall we say, when it comes to Podman. So this is going to come back with an error message. Now, you don't get this problem with Docker. But if I have a look and see what containers we've got, it's saying that we've got a container, which it isn't actually running, but it's called web server. That's what it's complaining about, is that, well, the name's already in use for a container. I can't create another container because the name's already in use. So, like I say, you don't get that issue with Docker, but what I'm going to have to do is just clear this container. So we're using Podman container prune -f, so I don't have to put a response in for a prompt. Hit return, and then it'll clear that container out. Then what we can do is run our web server again. So we'll just wait for that to start up. And then what I can do is to use ps aux and have a look at the actual processes that are running. So there's all sorts of processes being run here, plenty of them to do with Docker in here somewhere, and they're all being run by the root account. But if you look at our HTTPD container here, it's being run by my user account. There are some other IDs that go along with my account. So when you create the user account, you get sort of like your main ID, but you also get a range. So what you'll find is you don't just necessarily see your name, you'll see other IDs that you've also got access to. But essentially, this is not actually being run by the actual root account, and that's the main plus, the benefit that Podman's really bringing here. I mean, what we can do is we can just filter things out and have a look and see what root is actually running. So that's ps-u for the user account and then root. Let's hit return. So this is everything that the actual root account's up to. So like I was saying, these are all these things that have been done using Docker at the moment, because I've already got Docker installed on this as well. But yeah, I'd say that's the main benefit that Podman brings, is that if you just do that default installation, well, straight out of the box, you'll be able to run your containers with a non-root account, which is much, much better from a security perspective. But in any case, there are other things I need to do after this. So first I'm going to actually stop this web server. And then just to make sure that I don't run into any errors, I'm going to remove any unused containers using that podman container prune-f command as well. Now, if you prefer to use a compose file to actually store all the details of your containers, then we can do that with Podman here. But first what I need to do is to install Podman Compose. So sudo apt install podman-compose and then just -y so I don't have to answer the prompt. So it needs my password again. Put that in, and then off it goes and installs that. Now, just like Docker Compose, Podman Compose needs a compose file. So I'm going to use nano to create a file, and I'm going to call this one compose.yaml. Now, Docker Compose and Podman Compose, they're based on a standard, and there's certain names that they'll work with. I don't want to start causing confusion for myself and calling this one docker-compose.yml, although it would work, because, well, I'm using Podman here, not Docker. So that's why I'm going to call this one compose.yml. So I'll hit return, then I'll copy and paste in the details, which are basically just the same as when you're using Docker. So we've got our version compatibility at the top, then our services section, and then you start to define your container. So for this web server that's going to be running Apache or HTTPD, we've got web server here, and then we're pointing it to the image that we want to use for the container. I'm going to give it a name of web server. Then I'm defining the ports. 8080 is going to be the outside port. 80 is what the actual container itself uses. And I like to be able to have containers restarted automatically unless I actually manually stop them. So when it comes to the restart option, I prefer to use unless-stopped instead of always. So save this file. And then what we're going to then do is to run our podman compose command. So podman-compose, then up to actually run our containers, -d to do this in the background. And then it'll go through that file and it'll basically start up any containers that aren't already running. So this comes back with a lot more details than you normally see with docker-compose in comparison. But if we go to our website, I'll just do a hard refresh. Yep, it's still working. Come back to here. We've actually got Podman, if I could spell, and then ps-a. So there you go. Our actual web server is up, except this time we're running it using Podman Compose. Now, just like with Docker, you can also create your own images, and it is actually recommended that you do that. So first thing I want to do is to actually create a folder for where we're actually going to store our actual image details. And then we're going to switch over to that folder. And then we need to create our actual Docker file. Now, one thing I'm going to point out is that I've actually named the file Docker file, but it's actually capitalized. Now, if you use Docker, then normally you just have that in lowercase letters. But what I found is that if you actually have this in lowercase letters, it actually generates an error message. So do make sure you use that capital D. Now, I'm not going to do anything particularly wonderful here. I'm going to keep things as simple as possible. So we're just going to use that Apache image, and then we're just going to map a local folder into the container so that we can set up our own actual web page for this. We'll save that. Now, because I've actually told it to map an actual folder, what we're then going to do is actually create that folder. And then I'm going to create my actual index file within that folder. And again, nothing too wonderful here, just some basic HTML code. And then I'm going to save that. And then what we're going to do is to then actually build our own image. So basically it's the same as when you're using Docker. So in this case it's Podman instead of Docker, and then build -t to give it a tag or label. I'm going to call this my Apache. I'm not going to bother with an actual version, so it'll end up as the latest version. And then we want to use the existing or present working directory. So that's why we've got the path set to dot. Hit return, and off it goes and builds our own image. Well, this is now finished, and it's actually telling us that it's successfully built an image. It's called my Apache, and it's the latest version. But I'm going to always check to see what images we've got using Podman and then images. So you'll see that we've got the original Apache image that we downloaded, and then there's the one that we've built. Now, the thing is, I've already got a web server actually running on this computer. So if I try to run the one that we've just created, well, it'll clash. So for that reason, what we're going to do is stop that one. Then while I'm here, I'm just going to remove that container. And then what we're going to do is to run a container using the actual image that we've just built. So pretty much just the same command as we used before, except this time I'm going to give it a name of my Apache. I'm going to point it to this image that we've created called my Apache. So that's that one there. So hit return. And then what I can do is I can just run the curl command, for example. Again, it's a container. It's running on that same local computer, so I can point it to localhost. You can see it's coming back there with our index results. I hit refresh on there. Now it's saying this is my web server. So basically it's the same process that you use to create images for Docker. Now, although we're getting better security here by running our containers with a non-root account, there is a slight catch, and that is we can't get access to what are known as privileged ports. In other words, ports below 1024. So just to demonstrate that, what I'm going to do is to just switch back to the parent folder. We're then going to stop our container, and then I'm just going to clear that out. Now what I'm going to do is I'm going to try and run that container, but instead of mapping it from port 80 to port 8080, I'm just going to leave it at port 80. Hit return, and we'll just wait, but basically it'll come back with an error message saying that we can't get access to ports below 1024. Now, it's actually telling you there's a config file here where it's currently set to a limit of 1024. And you're going to run into the same problem if you actually set up Docker, for instance, to give you access to rootless containers. By default, you don't have this problem in Docker because everything's been run as root. So this is something you need to bear in mind. Because, for example, here I'm trying to run a web server. Now, most users, I would say, are just not used to typing in a port number in the URL. So that's a bit of a problem if we're forcing them to put in port 8080 each time. So these are things you need to bear in mind. So there are ways around it, one of which, as it says, is to edit the config file and change the actual limit. But what we're going to do is just have a look in this folder here, because what you can do is you can actually create your own config file to basically override that. And I do prefer that method, because then if this config file ever gets reverted back to the defaults as part of some sort of upgrade, at least our changes will stay intact. So we're looking in this /etc/sysctl.d folder. There's already one in here, a file called 99-sysctl.conf. What we're going to do is to create our own file in there. I'm just going to start with 98-containers.conf. Doesn't really matter what you name it, to be honest, as long as it's something that has meaning to you. And then I'm going to paste in our change, which is basically the line that it was referring to. Now, I'm going to set this to a limit of 23. Reason being is port 22 is used by SSH, and I don't want to run into the potential of a conflict where I've got a container that's running some SSH session, for instance, and it clashes with my actual host computer. So that's one reason I want to put that in. You can set this limit to basically whatever you like. You'll look at some examples, they'll just set it to 0, for instance, but I'm just setting it to that higher level above SSH, just on the off chance. So we'll save that file. Then what I need to do is to actually get this to reload the config. So we're using sudo sysctl --system, and it basically reloads its configurations, which includes that new file that we've just created. And off it goes, and it's saying that how it's changed this value to 23. But what you can do to check is to run this command, and it'll bring you back all of the actual parameters, but I'm using grep to filter them out, so that's the only parameter I'm particularly interested in. So as you can see, it's matching what we've got up here. It's saying that that's now set to 23. So what I'm going to do, I mean, if we do Podman PS-A, it's basically got an issue here. So what I'm going to do is I'm going to stop that. And then I'm going to clear that container out. And then this time we're going to run it again. So again, we're mapping it to port 80. So hit return. And there we go. So again, there's different ways you can check this. I'm just going to use, say, curl, for example. Now notice I haven't bothered putting in an actual port, because by default with HTTP, the default port is 80. If we go to the actual web browser here, just delete out 8080. There you go. It's working again. So that's how you can get around about this limit of not being able to get access to ports below 1024. But there are other things we need to do. So I am going to stop this container. Again, since Podman is being fussy, I'm going to remove the actual container as well. Now, typically when it comes to containers, you'll want to be running the latest version of the image. So when you first set up the container, you'll specify you want the latest version, and then when you run it, then sure enough, it should download the latest version. The only trouble is you'll have an image on your computer that's got a tag of latest, but over time it actually becomes out of date. So you do need to actually keep these images up to date. Now you can actually do this manually. So one way to do that is to first check to see which images are on your computer. So we'll run Podman images. So we've got one which we actually built ourselves, but then we've got another one which we downloaded called HTTPD. So what we could do is actually specify that we want this HTTPD one to be updated. Now, before you can actually update the image, you want to make sure that it's not in use. So what we're going to do is run this command, Podman PS, and it'll show us what's actually running. And at the moment, we don't actually have any containers running. But if you did actually have a container running, you'd want to stop it using the Podman stop command, and then you'd specify the name of the actual container. Now, in my case, we're not running anything, so we're okay and good to go. In which case, if I want to specifically update that actual image, I can run this command. So Podman pull, and then we point it to the actual repository where that image is, along with the actual name of the image, hit return, and off it goes. Now, in this case, as part of this video, we actually originally downloaded this not too long ago, in which case we've already got the latest version. So it's gone off and checked, but as it's saying, well, you've already got that anyway, so it hasn't actually updated. But if your image was out of date, then it would get updated. And then once you've done that, you can then start the container back up again. Now, if you're using Podman Compose, on the other hand, you can actually run this command, Podman-Compose, and then pull. So if you actually have a look at our compose file here, we've already got a container set up, which is this same HTTPD one. So if I run that command, what it'll do is it'll go off and check to see if we can pull down that latest version. So Podman-Compose pull, hit return, and sure enough, off it goes and checks to see if the actual version we've got's out of date. If it was, it would then update it. So there's different ways you can do this manually. You can either specifically select the actual image that you want to be updated, or as I say, if you've got a compose file and you're using something like Podman Compose, you can actually get it to update all of these actual images that you're using. The only thing you've got to bear in mind is, again, just make sure that you've actually got those containers stopped before you actually try to update any images. Now, the main appeal about Podman is that you can actually run your containers using a rootless account, and that is better for security. The only problem is, if I actually start up a container on this computer and then reboot the computer, well, the problem is the actual container doesn't automatically get started. So if I do want a container to survive a reboot, then I need to create a service. First thing I need to do, though, is to create a new user account. So I'm going to call this one Podman User, although I would suggest using something a bit less obvious. We'll use the user add command, -m because we want to create a home folder, then -s and specify that we want the bash shell. I just need to provide my password here for sudo rights. Then what we're going to do is to switch over to that user account. Go to the home folder. Now, what you do here really is up to you, because you could actually set up individual services for the actual containers. You could set up an actual shell script and get the service to run that. But because I'm using Podman Compose, well, I'm going to use that. So I'm going to create a compose file in this user's home folder. I'm going to call it compose.yml. Then I'm just going to copy and paste in same details I used before to set up a web server here. So I'll save those details. Then I'm done with this user, so I'm going to exit out. Next thing I need to do is to create an actual service file. So that goes in /lib/systemd/system, and I'm going to call this podman-compose.service because I'm actually going to get it to run the podman-compose command. Then I'm going to copy and paste in the actual details for this service. So when it comes to what we need access to the network. I want to make sure that the service is being run using the Podman user account. The type is one shot, main after exit set to true. Before we try to run the service, I want to do a bit of a cleanup. So running Podman system prune, then -f. In other words, I don't want a prompt. When the service runs, I want it to run Podman-compose. I need to point it to the actual file, so I'm pointing it to this compose.yml file, which is in the home folder of our Podman user. And we want to use up -d. In other words, we want to start up the containers, and we want to do it in the background. And then when the service stops, I want it all shut down, so I'm using Podman-compose down. So we'll save that file. Now, because we've added a new service, we need to update the daemon. So we're running this command systemctl-system daemon-reload. Then what we're going to do is to actually make sure that the service is enabled so that it starts automatically. And then we'll actually get it to start the service. Now, this is going to take quite a while because the way Podman's working is that every user has their own storage, if you will. So although I've already downloaded that HTTP image, for instance, for this user, well, the Podman user doesn't have it. So because I'm starting this service up for the first time, it's having to go down and pull that actual image from the internet. So for me, this is going to take a bit of time. So we'll just wait for the actual service to finish. Well, the service did finish, and the $64 million question now is, well, is our container actually running? Well, if we run this command, Podman PS, okay, we're not seeing any actual containers running. Well, if I run the curl command, so we're pointing it back to itself because we're running the container on this computer. The web server is listening on port 8080. Hit return, and we've actually got a web server actually responding. And the reason being is that, well, we run that service using the Podman user account, but we're actually logged in here using my account. And that's something you need to bear in mind. If you're used to running Docker with that default installation where everything is run using the root account, well, you'll be used to just being able to log in as a user and you'll be able to see all the containers running because the root account's running them. In this particular case, everything's been run on a per user basis. So my account isn't the account that's actually running this container, but it is actually up and running, as you can see by the fact that, well, the actual container is responding, or at least the web server that the container is running is. So yeah, it's something you need to get your head around when it comes to running a rootless platform like this, where your containers are actually run on a per user account basis, and you can have different users running their own containers. You won't be able to see what other people are doing quite so easily. I mean, what I could do is use PSAUX, for example, and you'll see that there's our HTTPD server there actually being run by Podman users. That is one way to find out, I suppose. But ultimately, we need to know, is this actual container going to come back up if we reboot the computer? Well, the computer is now back up and running, and I've logged back into it again. So what we're going to do to check to make sure that our container is up and running is to, well, just simply run the curl command. Point it back to itself, port 8080, hit return, and sure enough, we're getting a response from the actual web server which is running in that container. I can also go over to the web browser, point this to port 8080. Yeah, sure enough, we're getting a response on the web browser as well. So as you can see, by setting up that service to actually run Podman-Compose, we're able to actually make sure that our actual containers do survive a reboot. Well, hopefully, as you can see, it's relatively easy to set up and run rootless containers using Podman. The only catch is, if you're only using Podman to run containers and you want these to survive a reboot, for instance, then you'll want to set up a service account to automatically start them. Now, if you prefer to use a graphical user interface over a CLI to manage your containers, then you can install Podman Desktop to do that. One thing I haven't touched on mind, and something you may want to explore, is Podman also allows you to group containers into a pod. So aside from the security benefits and the simpler installation process, I think that's another benefit that Podman has to offer over Docker. But which do you prefer, Podman or Docker? Let me know in the comments section down below. Now, if you find this video to be useful, then do consider subscribing to the channel, as that would really mean a lot to me. But it's also a good indicator to let me know how videos like this are helpful to people such as yourselves that are watching. In which case, thank you. On the other hand, if you're not ready for that level of commitment, then I'd really appreciate it if you could press the like button, because that way that'll help to get the video out to other people that might find it useful as well.